Before starting the static alignment measurement on the lazar posture, first check the prosthesis length. Next, conduct a step test to assess whether there is sufficient socket flexion in the alignment. If both feet remain on the same level, this indicates that a hip flexion contracture is fully accommodated, and you can continue with the sagittal measurement. For a valid measurement, several criteria must be met. Ensure that both feet are positioned at the same level on the lazar posture, that the knee joint is fully extended, and that the user is standing upright. Check in the app whether the body weight is distributed equally on both legs. At least 40% of the user's body weight should be placed on the prosthetic side. Now, the ground reaction forces in the sagittal plane can be analyzed. The lazar posture displays both load lines simultaneously. We recommend using the comprehensive 3D measurement mode to examine the load line on the prosthetic side. The load line should originate from the middle of the foot, run 20 millimeters in front of the knee axis of the mechatronic knee joint, and run vertically, which indicates minimal horizontal compensatory forces. The alignment should allow relaxed standing with both load lines lying as closely over one another as possible. If the ground reaction forces differ from one another, the static alignment should be optimized to ensure a stable and more relaxed standing posture. In this example, we observe a typical situation after bench alignment. The load line originates anterior to the middle of the foot. This is often caused by too much plantar flexion of the foot, which shifts the load line anterior and tilts it backward. Users often describe this as a feeling of being pushed backward by the prosthesis. Adjusting the flexion angle of the foot should improve sagittal alignment. We recommend making gradual and limited adjustments during the optimization process. After dorsiflexing the foot, the pressure on the forefoot is relieved. The load line shifts to the middle of the foot and runs more vertically, which supports a more relaxed standing posture. In this example, the step test results in an anteriorly positioned prosthetic foot. This indicates that an existing hip flexion contracture was not fully accommodated during bench alignment. Another sign of this condition would be a visible hyperlordosis when standing with both feet at the same level. To increase socket flexion, the socket needs to be tilted backwards and shifted anteriorly. Ensure that the alignment reference line runs through the socket reference point. A subsequent step test shows the improvement after making changes to the bench alignment. Now, the ground reaction forces in the sagittal plane can be analyzed on the lazar posture. The orientation of both load lines indicates an appropriate static alignment for our user. Finally, we measure the ground reaction forces in the frontal plane. Using a tablet stand for the measurements keeps your hands free and makes working with the lazar posture even easier. The load lines on both sides should lie close to the center of the knee. Be aware that a certain level of horizontal force is normal in the frontal plane and results in slightly tilted load lines. Do not forget to tighten all screws to their specified torque after adjusting the alignment, and to calibrate the knee joint once the static alignment optimization is complete.